Okay, here's your sample problems. 2-5, day 2. Just take a look at page 105, example 4. You've got the story problem where, let me take a peek. This young lady, Libby, is trying to make a rectangular pasture enclosure that's in the shape of a rectangle. So if you remember from the pre-lesson, we've got the length here, we've got the width here, and then they give us a few limitations or parameters about her particular design or situation. She's got 340 meters of fence. She wants an area of 6,000 square meters, and they want to know what the exact dimensions of her pasture can be. And believe it or not, we're going to use what we've been working on to solve this. But we're going to have to use those two formulas. The first one is the area equals length times width. Notice she wants an area of 6,000 square meters. That's the language of area, okay? Also, if we know that she has 340 meters of fence, that means if I go from point A to B to C to D and then back to A, that whole perimeter, this length plus this width plus this length plus this width is going to add up to 340. So that means 2L plus 2W equals 340. Now, what you guys have, you haven't done this yet this trimester. You guys have been dealing with this. 2x minus 3y equals 6, and 4x plus 3y equals whatever, 12. And I just made an easy one because if you add these together, these will cancel. You get 6x equals 18, and you just move on and solve the whole problem. Now, something different is going to happen. Notice this is a linear equation, and nothing's squared. My x's aren't squared, my y's aren't squared. So that's how you would handle that system of equation. We have another system right here. Something's going to happen though. So what we have is length times width. See, no problem in our past this trimester did we ever have x times y in any of our systems. That's going to throw us a little curveball. But don't panic. Watch this. First thing that's going to jump out at me is this one. I can just divide by 2. So you're always trying to make your life easier, not harder. Well, what if I forget to do this? Now the numbers are going to get enormous. They're already going to be big. So this would spit out length plus width equals 170. And that shouldn't shock you because if it's 340 all the way around, then technically what they're saying is it's 170 if you just go halfway around, length plus width. So we're going to use this one. And we're going to use our good friend substitution. So we could subtract W right now, or we could subtract L right now. But what I'm going to do is subtract W. And I'm going to see that length equals 170 minus W. And the reason we're doing that is because now we can see, I hope, that you can use substitution. We know that length equals this. So we're going to take this and put it in for that guy right there. So we get 6,000 equals 170 minus W. That's the length times the width. I kind of drew over that. So now we're going to distribute. So we get 6,000 equals 170 W minus W squared. Let me pause this a second. Okay, so what I noticed was the book did things slightly different. I said you could subtract W or L. The book actually subtracted L. I'm going to show you this method. You can see the book is similar, but they solved for L first by doing things opposite. But we'll just push forward here. What we have, and I have my calculator, what we have is a trinomial with huge numbers. Remember, we want our squared term to be positive. So what I'm going to do is subtract 170W, and I'm going to add W squared, subtract 170W, and add w squared. I'm going to condense that into w squared minus 170w plus 6,000 equals 0. Now, it'd be nice if that was a perfect square trinomial, but it's not. So that's why we've been learning completing the square, and that's why I've got this handy-dandy calculator. So this is a 1. You like that. We're going to complete the square here. So w squared minus 170w plus space plus 6,000 plus space. Now, half of 170, let's see here, clear this out. Half of 170 would be 50 plus 35, that'd be 85. So now I have to square that monster. 85 times 85, 7225. So I should have had more space there, but that's 7225. And this is got to be minus 7225 equals 0. I know it's crazy looking, but this right here is a perfect square trinomial if I was to put brackets around that, which I know is going to be w minus, because of that. Now, if I just take the square root of that number, it'll tell me what to put in that blank. So give me a second. So that would be 85, just using my calculator, squared, and then what do I have here? I've got minus 1225 equals 0. Now, in order for me to use bada boom, bada bing, and do the right thing, I got to add 1225 to both sides. And as crazy as this thing looks, just because of the large numbers, don't panic, equals 1225. So I'm going to take this bada boom, bada bing, do the right thing. So I get w minus 85 equals, plus or minus, let me pause this a second. Okay, that ends up being plus or minus 35. So if I add 85 to this side and add 85 to that side, these cancel. I get w can equal 85 plus 35 is actually 120, or 85 minus 35 gives me 50. Now it asks for the dimensions, the possible dimensions. So if we take a look at this, we have two possibilities for our w. So if we take the first possibility, where w equals 120, and I put that in here, and I put that in here, that leaves me, so I got 240 that I've used. That means if I have 340 total meters of fence, I've only got 100 meters left to share between these two sides. So that would mean this is 50 and this is 50. Now, let's change gears. So one of my answers would be 120 by 50, and those are meters. Okay, but wait a minute. What if I looked at the other piece of information that it gave me, and it said, or my width could be 50. Well, if I said, hey, that's 50 and that's 50, you can see that now I have 100 meters of fencing that I've used between the widths, and I have a total of 340 meters of fencing total. That's 240 to share between the two lengths. If I cut that in half, that'd be 120, and that'd be 120. So in a sense, it just gives us the same dimensions. Now, typically the length is longer than the width, so I would say this is the more likely answer, but it doesn't really matter. A lot of math, but you can see how it's, you can actually apply this stuff to some real life example problems. All right, hold on a second. Okay, this one is more of your pure math, like math, not actual applications. This is just get her done. Put it in vertex form. Does it have a max or a min? Remember, a max is going to go like this. A min is going to go like this, and they don't really want to know any other details about the stretch or compression or translation. So we take a look at this. Hopefully you need to know, or you should know, don't mess with that Don't attach anything to it. So we are stuck looking at this and saying, hey, it'd be sure would be nice if that was a perfect square trinomial, but because that's not a 1, we know that it just can't be. So it must be a 1. So you're like, oh, divide everything by -2. Oh, no, you didn't. What we're going to do is we're going to take a look at these two, and we're going to kick that over. Why wouldn't we subtract 1 from both sides? We just want y, because it asks us to put it in vertex form. You want y by itself. So kicking that to the curve, y equals, I'm going to take out a -2 here, because I need that to be a positive 1. So I have x squared minus 5x. Now, what happens here? Well, take a look at this. You're like, this times this gives me my 10. Plus a space. You don't like it when that's an odd number, but we're going to have to deal with it. And then plus 1 plus space. So, yuck. Take half of -5. We don't want to introduce decimals, so we're going to say that's -5/2. We square it, and we get 25/4. Now it gets a little tricky, because I'd like to just say, oh, put -25/4 there, but remember there's a -2 that hits that. So -2 times 25/4 is actually -50/4, which reduces to -25/2. So that's actually what I added to this side, a -25/2. So I got to do the opposite by putting 25/2 here. All right. Now, if we've done our math right, we can put 100% of our trust in that this is a perfect square trinomial. It's just really weird looking. So I go y equals -2 times x, because that's a minus. I know that needs to be a minus. How do I figure out what goes here? Just take the square root of that term, and it works. Believe me, 5/2. If you don't believe me, then you're going to have to go x minus 5/2, x minus 5/2, FOIL it all out, and you'll get this, I promise, but we just don't have time to do it. And then what do we have here? Well, that's 2/2 plus 25/2, which is 27/2. Now check it out. Vertex form. Well, get it. Where's the vertex? Well, that's going to be 5/2 to the right, 2.5. Then we're going to go up 27/2. So what would this look like if they ask us to graph it? 5/2 is like 2.5. This is like 13.5. So I go over here to 2.5, and then I go up to like 13.5. And because that's negative, it's going to be skinny and it's going to go down, which tells us it has a max. And that's the maximum value of this actual problem. If they ask for the actual point, it's 2.5, 13.5, which is the same thing as that. So there you go, completing the square. Some are hard, some aren't so bad.